Hello, everyone. Thank you for coming to our talk today. So my name is Anil, and I'm with a company called Overclock Labs. That is the company behind Akash Network, which is the open source project we're going to talk about today. And then with me is Logan from a startup called ThumperAI. That is one of the most active users of Akash. So what we're going to do today, we have about 15 minutes for this talk. So what I want to do is obviously show you all how you can use Ray with Akash for training and other things. And so we'll do two things. We'll try to show you a demo of deploying a Ray cluster on Akash, and hopefully do that in a couple of minutes. But I'd also like to have Logan talk about how he's used Ray on Akash, specifically to do some AI model training. But before we get to that, I want to give you a quick overview of what Akash is, because I assume most people here are hearing about us for the first time. And then at the end, I'm going to have something interesting, hopefully, for people that are from startups or from small teams over here. So let's dig in with a quick overview of Akash Network. So to understand Akash a little bit, just a quick review of the public cloud model today. So obviously, in the public cloud model today, you have infrastructure that's owned by a single entity, like AWS, for example. And you have a bunch of users that connect to that infrastructure. And this model obviously has worked really well for the last 20 years, primarily because it has enabled a huge amount of innovation for startups. So if you think back when before the cloud existed, if you were a startup trying to build something new, you had to put a huge amount of money in terms of capital expenditure up front, and that was a huge barrier to entry for startups. And that kind of killed a lot of the innovation that could have happened. Cloud enabled startups to be able to go and spin up their services without having to put that huge amount of capex up front, and it's been extremely helpful in terms of driving innovation. So I guess the question then is, why are we trying to change the existing cloud model with Akash, which is what I'm going to talk about. So there's kind of two things I want to bring to your attention. The first is, even though there exist these really big public clouds in the world today, there still are a huge number of data centers across the world. So depending on who you talk to, there's anywhere from a few hundred to several thousands of data centers distributed across the world. And these are all independent data centers that have maybe one location or two locations, and they may have a few hundred or a few thousand servers. On average, most of these data centers, we have spoken to a lot of them, and most of them tell us that they only end up utilizing about 20% of the server capacity that they have, and the remaining 60, 70, 80% gets either underutilized or not utilized at all on a daily basis. And so what we figured is, if there's a way for us to make all that server capacity available to folks that need it, we can realize some gains on both sides of that equation. So that's one aspect of it. The other aspect is, in the last couple of years, as AI has become more mainstream, what has happened is that there's been a huge amount of strain on availability of accelerated compute, aka GPUs, because there's only one vendor producing those. And so what that has caused is that even at the super hyperscaler public clouds like AWS and GCP and Azure, if you're a small startup and you want to, let's say, use Llama 3.1 today to go and do some inference, you would need potentially 8 to 24 H100s. And if you want to get those from these public clouds, it's going to be a problem, because they would expect you to commit to a cluster of 64 such GPUs for 1 year. And so effectively, you're kind of spending a huge amount of capex, even if you're using the cloud for GPUs. So that kind of disrupts the old cloud model and brings us back to the old days. So what can we do about this? So here's what Akash has done, is we have basically built what lots of people like to call the Airbnb for cloud compute. So what we do is we work with data centers all across the world, and that's all the providers that you see up there. Each of those, think of those as a single data center with certain amount of capacity. It may be the entire data center, it may be a portion of it. And what we build is a software layer that sits between them and the users that want access to that compute. And what we're able to do in the process is realize some benefits on both sides of that equation. So what do you get for using Akash? You essentially get a lot of things. You get a lot of locations in the world. Akash today has over 65 data centers across the world that work with us, and we're hoping to take this into the several hundreds over the next few years. So that's way more regions already than what you can see with the public clouds. But the biggest benefit, obviously, is on the GPU side, which is accelerated compute. On the right side of the slide, you can get access to an H100, for example, on demand for $1.45 right now on Akash. Similarly, you can get access to an A100 GPU for under 80 cents an hour on demand again. No reserve, no need to commit to a year, no need to commit to a 64x cluster. And then on the regular compute side, on average, you save about 30 to 40% relative to what you can get from AWS. And you can go to the URL down there, akashnet.network/GPUs, and you can check out a live version of both of these pages. Cool. So the other aspect that's unique about Akash that I hope a lot of the folks here will find useful and interesting, because I'm assuming there's a bunch of people that work on open source software, given that this is an open source summit, is that Akash not only uses open source software, namely Kubernetes and Docker and a whole bunch of other things, but we also are good open source citizens in that we take all of the stuff that we've built and we open source it. So if you go to github/akash-network, you can literally see every aspect of the essentially the services that make Akash run. All of that is open source today. And then not only do we stop there, we actually take it one step further, and we actually have a 100% open development model as well. So what that means is all the work that happens on Akash, whether it's new features, whether it's participating in events like this, whether it is marketing, anything, all of that gets discussed in the open. And so what we have is a model very similar to what you've seen, for example, with the Kubernetes project, where they have special interest groups and work groups. And these special interest groups meet on a regular basis. They talk about various aspects of the project. So in our case, we have special interest groups for providers, for clients, for deployments, various things, right? And so that's one aspect of it. And then you can see below all the meetings that happen as part of those special interest groups and the steering committee, which kind of guides the overall project. All of those are also stored on GitHub as well. So it's an amazing project to get involved with. Talking one level deeper, because I'm assuming most of the folks here are technical, I'll get a little bit into the weeds. This is the typical deployment workflow that you can expect to see on Akash. Looking sort of from the left to the right here, you as a user, you bring your application, which could be a workload, it could be an AI inference app, it could be a web service, it could be a static web page, I don't care. You containerize that, and then you write something called an SDL file. SDL stands for Stack Definition Language, and it's basically you specifying, you as an ops engineer or a DevOps engineer, specifying what you think is the resource requirements for that specific workload. So GPU, CPUs, memory, storage, etc. So you do that, and then you submit that to the network. And when you do that, what happens is Akash takes your request, and it broadcasts it across all of the providers on the network. So there's over 60 of them today. Every single one of those providers receives that request, and it looks at it and says, hey, can I fulfill the requirements of this request? And if it can, then the provider responds back with what's called a bid. And so what you see is you see a whole bunch of bids come back in response to your request. And then you can pick the bid that you like based on price, based on location, based on a whole bunch of attributes that each of the provider exposes. And then once you pick a bid and say, this is the provider I want to choose, then Akash goes ahead and deploys your workload onto that provider and gives you a entry point into it. And that's something that you define as well. So it could be an SSH session into it. It could be a HTTP endpoint. It could be anything. So I talked about SDL. So let's look at really quickly what the SDL file structure is. So this is what a typical SDL file looks like. This is a simple version. You can get really complicated with this. But anybody that's done Docker Compose here should find this very familiar. But just to sort of break it down a little bit, there's kind of 4 or 5 sections to this. One is a section where you specify all the apps and services that you want to be running. You can have any number of those. What you specify there is the container image, the ports you want to expose. You can also pass environment variables and command line arguments to it. The next section is the compute profiles for each of the services. So this is where you'd specify what you need in terms of compute. And then below that is information about which providers you want to work with, followed by how much you want to pay. So you can actually set a limit and say, don't show me any providers that exceed this price, right? So you can actually put a filter on that. And then the last is how many replicas you want to run on that service. So that's the SDL file structure. what I want to do next is, in the next 5 or 6 minutes that I have, I want to show a demo of deploying a Ray cluster on Akash, if I can do that. But before I do that, I want to invite Logan to talk about how he has used Akash with Ray for AI training.
Thanks, Anil. Yeah, so my company, ThumperAI, we wanted to train a Creative Commons text-image model that would be for artists who didn't want to use data that had been acquired based off training on copyrighted images. And we had a really hard time getting GPUs from large public clouds. And we were very frustrated by that. And we went to Akash and we said, wow, like the GPU prices are insanely better. This is sometimes like 50, sometimes like 80% less than what than AWS, and often very much cheaper than even the next closest. But the ultimate question is, like, can you run what you really care about in the real world? And for us, for our text-to-image foundation model, we wanted to use Ray with that as well as Ray data. And so in order to do that, we went onto Akash, we created a 64 A100 GPU cluster. We used MinIO instead of a big cloud provider S3 bucket, and we were able to successfully train our AT1 foundation model and do it using the infrastructure that exists today on Akash. And we would have saved a huge amount of money relative to training it on AWS or at any other cloud provider. And that assumes that we could get GPUs from them.
Awesome. Thank you, Logan. So what I'll do now is, I know I have only a couple of minutes. I'll try to see if I can show you a quick demo of trying to deploy a Ray cluster here. So, and I'm going to try to do this live. So if there's Wi-Fi issues, then we'll deal with that. But here is what I'm logged into is Akash console. Think of this as the equivalent of AWS console, but for Akash. What we have here is a whole bunch of templates that we have pre-created for various AI workloads and databases, all sorts of things out here. What I'm going to do here is just search for Ray. And of course, you can create your own custom templates as well. But just search for Ray. So I have a Ray cluster template here. Click on this guy. It's probably a little slow because there's a whole bunch of people connected to Wi-Fi, but I'm going to click on deploy. So I talked about that SDL file before. Here is the version for Ray. It's a little more complicated than the one I showed, but it's still the same idea. You've got a Ray head service. You've got a Ray worker service. You're exposing some ports, and you're setting some environment variables and command line arguments. So I'm going to go ahead and click on Clear Deployment. It's going to ask me, these are the two services. That's the amount of resources I want to allocate. Confirm. What's going to happen now is it's going to, as I mentioned before, it's going to send this request over the network to all the providers on the network. The providers that can fulfill it are going to respond back with a bid. The ones that cannot won't. And so hopefully what we should get back is a whole bunch of bids right now. And again, this is happening live over the network, so bear with any sort of latency issues here. So there you go. You're getting a whole bunch of bids back. And on the top right, you can see that it's looking for even more bids. What I'm going to do is just pick one of these here. This is in RTX 6000 cluster. It's located in Quebec. I'm going to click on Accept Bid here. So what I'm doing now is I'm saying, OK, I want to work with this specific provider. So think of all of these as a little tiny AWS running somewhere out there. And so what's happening now is that Akash is taking your workload, and it's deploying it on that specific provider there. While it's doing that deployment, what I'm going to do is show you a quick overview of the network. So this is the network as a whole. There's a total of 63 providers in the world right now. Think of each of these dots as one single small data center. So the dots are not representative of the total number of servers, but the total number of data centers. Here is the aggregated network capacity across the world, all the providers, individual providers out here. So that's just an overview. Go back to deployments here. Here is the Ray cluster I just deployed. Hopefully the logs are coming up on this one. Let's go back here, actually. OK, so that's the logs coming from the Ray cluster. You can see it's running. Click on the leases here. And it's exposing the port internally to the Ray worker. Open up this, and there's my Ray cluster running. So that's a quick demo. Would love to show you guys a lot more. We have a booth out there in the corner there, so please stop by. Here's a few other people that are using Akash today. There's a lot more. This is just a few names. Two that I'll call out. One is called brev.dev. It's an application for doing fine-tuning of various open source models. Brev just got acquired by NVIDIA, so they're technically part of NVIDIA now. News Research is one of the leading model developers. So they've developed a model called Hermes model, which is in the top, I think, 10 in terms of AI models. And then we also have a few universities that are using us, UT Austin and RIT. Last, I'll leave you with this, which is if you're a startup or a team that is small enough that you can't get GPUs in the bigger clouds, or you're looking to get started and looking for some sort of credits, come see me. You can also email me if you can't stop by my booth. That's my email address. And then if you're here today evening and you're not doing anything, we have an AI mixer happening about a half a mile from here. It takes about 10 minutes to walk. That's the QR code. You can scan that and sign up for the event, register for it. And if you can't grab it right now, again, stop by our booth. Thank you all. Appreciate it.